Alright guys, welcome to my video for the final project in Digital Logic. The first thing I'm going to talk about is how I implemented this in the Verilog. Then I'll go in and show you some of the test benches that I created to get my project to work. And then I will go over the ASM chart, and then I'll show you how it works. So first things first, is this how I call, or this is my main module. These are some of the imports. It's really kind of hard to see, but these are all my inputs, outputs. You can see this is how I guessed. I used these switches on the DE0 board from 0 to 9, which gives me capability of guessing up to 1024. Okay, these are the connections between my modules, which I'll show you, and then these are the outputs, which go to the 7-segment displays. Call for the BCD to binary, which is where my switches come from. Just how I turn my switches into a decimal display. I'll go over that more in detail because that's something a little bit complicated. This is my call for the 7 segments. I'll definitely explain this because I actually got mine to do some scrolling, and so I will show you a little bit more on that. Then I call for my control module. This is a step in my process where I actually control the value of the button so that it stops my counter that counts from 0 to 1000, and then it takes that input and brings it into my another register, which again I'll go over in detail in a later module. And then this is the call for the counter, of course. This go is actually telling you when I've stopped the counter. It sends out a light, which I'll show you on the DC board. And then, this is just your basic modulo counter. You have a clock, which is the 50 megahertz going in. You have the reset, and then the output is the actual what we're guessing at. And the reason this is somewhat random is, like I said, it goes from 0 to 999, but it's constant. Because it's counting so fast and it's constantly going. You could press the button anywhere from 0 to 999. And it, when it's going at I don't know, 50 megahertz, it could be anywhere in here when you press it and stop it. So that's what gives it its randomness. Pretty cool. Alright. Yeah, and then I also call for my compare, which, like I said, I'll go more in detail. But this also is a clock, send, guess, switch, which is the input. The guess is the input from the counter. So these two are the 10-bit numbers that are being compared. And then these are my outputs here, high, low, and win. And yep, that's it. Okay, and then I also made a, these are calls, but I called for a divider, which I'll explain what this B is. It's how I got my scroll to work. And the counter for the B is the actual number for B, which, like I said, I'll explain in detail. So first off, we're going to go through the compare. This is how I implemented it in Verilog. Of course, I have, like I said, all the inputs and outputs. Input, clock, send, input, guess, and switch, which are both 10 bits long. And then these are my signals out, high, low, and win. High and low are just going to be LEDs that tell me whether I've guessed high or low. And so this is the business end of the code right here, though. So if send, which is one of the buttons, the push press buttons, right? So when it's just sitting there, these values don't do anything. So high, low, and send are going to be 0. And that's exactly what I wanted, because I don't want anything displaying until I send my guess over. And this is another thing. I've kind of made a Mealy type state machine, which I'll show you at the end of this. The Mealy type is because it depends on the input and the current state. So now this is else if. Now it's kind of hard to see, but that's a not send, the little tilde sign, and switch is less than guess, just comparing the numbers. So if switch is less than what I'm guessing at, low is going to be 1, high 0, win becomes 0. Alright, and then I also made a similar statement. I'm not writing all my code because there's really a lot, but I think you can get the gist of what I did. So switch greater than guess and not send would be there. Then it would just be high equals 1 and the other two equals 0. Now, if I ever get my guess right, which I always do, else high becomes 0, low becomes 0, and then when becomes 1. When's not an LED though, it's just a signal to a counter and a multiplexer, which I'll show you even more. And that's how I did my comparing. Worked out pretty well. Alright, now this is how I got my BCD digits, which I'll show you to show up real time. As I actually switch my switches, it shows the number that I'm guessing in decimal. So you have your input switch, which is a 9, of course. Output reg is 3 to 0, which is that binary number. You have the ones, tens, and hundreds. Okay, and then I have an integer I, which is super important, and it'll come in later in the code. Okay, then always at switch. Now the switches are the switches. So hundreds is a 4-bit decimal number. Notice they're in decimal. Tens, 1, same thing. Now this is the I. For I equals to 0 in the beginning, then less than or equal to 9, I plus 1. So this is just a for loop that increments through 1 through 9. Now to convert a binary number to decimal, what you have to do is if the hundreds position is ever greater than or equal to 5, you have to add 3, and that's what I've done here. And I did similar things for the ones and the tens place. Like I said, I don't have enough time to show you all the code, but that's how that works. And then you always have to shift left 1. So if you have this 10-bit number, it always goes over 1. Doesn't matter if it's greater than or equal to 3. And then this is where the switches actually come in. So ones is 0 is equal to switch of I, and that's that I counting through. Little confusing. I wish I had more time to explain it, but we have a 10-minute video. Alright. Now this is how I got my scroll to work, which is, I think, pretty cool. So basically I have my module for the call to 7-segment displays, right? Just like we saw in the book, except for they're inverted. You have the BCD output and everything like this. And 0 through 9 is normal, just like in the book. But what I did is I made 10, 11, 12, 13, and 14 added on to my case list. Just, you know, back on. And then, so 10 is C in my name. So that's what it would look like. This would have to be 0 or 0, 0, 0, 0. So that's what that corresponds to. I did a similar thing for H, A, and D. Just like this. I didn't put them in just because, you know, it's pretty basic. And then 14 is just a blank spot. This is how I created a space in the scrolling. And then I come down here. This is the actual call for the 7 segments in the main module. And what I have here is the conditional statement, which acts as a multiplexer. So when I get my guess right, I have 10 plus B, B being a number between 1 and 4, or 0 and 4, right? And so when it's just 0, C comes out. Alright, and then if it's false, it's 14, which is a blank. So that's what I would get on the 4th furthest most digit, and I'll show you. And then I come down here, and for the hundreds digit, I do the same thing, except for I do B plus 1 modulo 5. Once again, giving me a number between 1 and 4, which really, 1 and 5, which causes it to cycle 1 ahead of this, 1 ahead of it. And then for the tens place, I do B plus 2, and for the ones place, I do B plus 3. Works out pretty well. And the way this basically works is the first digit is going CHAD space, the second digit is going HADC, ADCH, and there's always a blank after the D. So it kind of appears that it's scrolling, but I'm actually not doing some sort of shift register or anything. It's just sequencing through a number. I thought it was pretty clever. Alright, and now I'm going to show you the circuit and my test bench. So give me 1 second. Alright, so now we're looking at, let's see if this works. Yeah, okay. So now let's do my test bench first. Okay, this is the test bench for the comparator, and basically that's just the testing. You can see between the high and the low going at different times. So one number is 512, that's the number I'm guessing at. So at 1, low is going high through here, and then at 712 you can see that low goes high and high goes high. Makes sense? Alright, and then down here they both go high, which is something I implemented at first, but that's just that's the wind signal for me. Alright, now let's go to look at the circuit, what it looks like generally. Try to point it out. We have this is divider circuit, the control button that I was telling you about, how I get my counter to stop. You can see that it's directly hooked up here. And this is the BCD, and this is the B-dub, which is kind of funny, but that's how I got the scrolling. And this is my comparator, and they all go to some outputs over here, and you can see a lot of the modulus and stuff like that. So that's what the basic circuit looks like. Now let's look at some of the code so you actually know that I wrote the code. Oh, the test bench. So here's the test bench. Basically, you want you want the inputs to be reg, which you can see here. Those are the inputs into the module: clock, send, guess, and switch. And then anything that's an output, you want it to be a wire. And then you do an initial statement, begin, set the values of your registers right here, and then you always go through a clock and not clock and an always block, which is just basically, you know, how you do a test bench. And I did 2 test benches, one for my comparator, one for my counter to make sure that it was stopping. And I will show you that code real quick because I think that's pretty important. Yeah, okay, so let's see if I can find it real quick for you. Yes, compare. This is what it all looks like. I got over 150 lines of code, I believe. Yeah, that's the code for the guess comparator right there. And then I have, this is my modulo 1000 counter, how I got it to work. And real important is that when that button actually gets pressed, you have Q becomes Q, and that's basically how I got it to stop. Worked out really well. So I'm already at 12 minutes. I'm just going to go ahead and show you the working guessing game. Alright, sorry. Okay, so basically I've already went through the guess. I know that my guess is 498, but I'm going to go ahead and go to 499 and show you what happens. That's the light that tells me I'm too high. Then I'm going to go to 496. That's the light that tells me too low. Then I come over here. Bam. Nope, sorry. 498, and that's it scrolling my name when I got it right. Nice. Okay, and then basically anything else, this would be to clear to reset my guess. Alright, then now I'm ready to guess, and the way I set my numbers, the way I do my guess, come on, there's a switch in there still high. Okay, so now basically you come by 256 or 512 would be your first guess. Come over here, that's too low, so you come over, do this, that's too high, and then you just work your way down. We're done, guys. Thank you for watching my video. Hope you guys have a good luck on the final, I guess.